In this video, we are going to learn PyTorch aggregate functions. First and foremost, we'll import torch library, then write some torch functions like torch.arrange and give some random values. Starting point and then ending point, let's say giving the step value 5 and hit enter and run. You can see at the interval of 5 I'm having so many values starting from 0 till 95. It's excluding the last value, that is 100. So how to find the minimum, maximum, or the average or mean value of this series? So I'll use print function, then f, then find the minimum value, and then write some x dot min and just hit enter. So in order to print the maximum value, I'll copy this code, go to the last and hit enter. So instead minimum value, I'll write maximum here, maximum value, and write x dot maximum, right? So I'll print both these functions. It's having 0 minimum, 95 for maximum. Suppose I want to print the mean value of this series. The mean value x dot mean. So it will give error. So what kind of error it is? It is data type error, must be either floating point number or complex data type. But we are having float data type, means we are having integer or whole number data type. So for that, what I will do, I'll convert the data type. So first I'll typecast the data type like type, and then torch dot float 32, and then enclose it, and then dot mean, and then print number. So let's check the pairing of this parenthesis. So first this is done, so then this is done, then this is completely pairing. I'm going to hit that value. So it's showing unmatched. Yes, one extra round bracket is there, and I'm going to hit run. So it's giving mean value 47.5 by converting integer value into the float 32 data type. So it's kind of typecasting. You can do the typecasting in the torch in this way, same. So you may have find some methods like mean, float 32, and so on. I can do the same thing in a different way, like torch that max with x. Hit enter. You can see it's giving tensor 95. I'm having 95 value. So 95 is the maximum value here. I can have torch dot min x. So I'm having minimum value 0. Similarly, I'm having torch dot mean, and then perform the typecasting x dot type, and then inside the round bracket I'm having torch dot float 32, right, and hit run. I'm getting the mean of the given series. Similarly, I can write torch dot sum and then hit run. So but I have not provided the input parameter, so hence it was showing the error. So once I have added the input parameter x, so and tensor 950 is the summation of my entire tensor flow. So then we will have another number, like what's the another functions and another value, right? So we can have lots of like integer. We can convert into different integer 8, integer 16, and integer different values, right? So we can have other parameters like reshaping the reshape. All right, suppose I'm having x, z, let's say x again. X is equal to torch dot arrange, and then 1 dot comma 8 dot. So what's dot here? It's the element wise. So this element is having x comma x dot shape. I'll have x comma x dot shape, right? So you can see the first value is having range 1 to 7. It's excluding the second value, and the torch dot size is 7. It's having 1 to 7, which means it's a 7. So I can check the D type, right? So D type is float 32. By default it's giving float 32 value there. So I can have x reshaped is equal to x dot reshape, and then giving the 1 comma 7. All right, then I just change, like I just copy this. Let's see, copy this parameter name x dot reshape. Then I'm going to check the parameter, the shape of this parameter, new parameter. Now you can see it's having 1 comma 7. Now previously it was 7 only, size or shape was 7. Now it's having 1 comma 7, which means I have reshaped the size. All right, so we can change, or means we can have the another parameter like x, and then having colon for remembering the changing view of tensor. So only creates a new view of same tensor, and I'll have colon comma 0 is equal to 5. Let's say 7 here. So I'm going to change x here and just hit enter. All right, so too many indices and too many parameters are there, right? So it can be converted as a reshaped value, right? So I'm going to reshape again, and you can see it's having reshape now. So starting from 0, then equal to 7. So the last value or the first value is just changed. So 1 is changed to 7, and rest is remaining same, right? So you can see I have changed, assigned the particular value or given the change value to the original value, right? So I can have more values also, like x underscore stack. If we want to stack our new tensor on top of its first 5 items, we can do that. So what we will do, stack is equal to torch dot stack, and then this one, and then x comma x comma x comma x, and then comma dim is equal to 0. So it's going to try changing the dimension to dimension 1, and let's see what other changes are there. So I'm going to print that x underscore stack and just hit run. You can see it's having x x x x, means first is the number, and 1 2 3 4. So 4 times it's going to print here. Suppose I'm going to increase one more x here, you can see one more rows are increased inside my tensor value. So it's going to reshape the value entirely. All right, and you can have the entire function and entire selecting values. All right. Suppose we want to have any image parameters. All right. So inside the image parameters, I'll choose image original and give random value. The torch dot rand and give size is equal to, let's say, 224 comma 224 comma 3, and then hit run. I'm going to print x original, then run. You can see the random values are printed on the screen and I'm having an image pixel values here, though it's not the complete index value or the real image, but however I have created the matrix value or the tensor value of the given image. So I want to print x permute the original tensor to rearrange the access order. So I'll write x permute and then x underscore, what is the original value, name x original. So I'll write x original and then perform a dot permute function and 2 comma 0 comma 1. So that's going to shift 0 to 1, 1 to 2 and 2 to 0. All right. So it's going to perform 0 to 1, 1 to 2 and 2 to 0. All right. I'm going to hit run and try to print that value. You can see my shape has been changed and it is going to convert it into bigger format, though values are 8581 2149. So you can see 8581 21849 and so on. So the values are same, but the functions or the entire values are changed. So shift access, it's going to shift access. So 0 to 1, right? 1 to 2, 2 to 0, right? So x underscore original dot shape, I'm going to print that shape and I'm going to check the shape of new one. So you can see the x. Okay, the original size was 224 comma 224 comma 3, but now it's a 3 comma 224 224, which means the values are now converted into 3. You can see 3 rows are there in each, but if you will ask to me how many rows are there, how many, so I will say 224 and 224 column. Similarly, we will have the 224 here also. So this is how we can change the particular value and particular index value, right? So now I'm going to have second reshaping value, reshape again. So what I will do, I'll write x is equal to torch dot arrange and then 1 comma 10, and I'm going to reshape that. I'm going to reshape then with 1 comma 3 comma 3, right? So 3 are 9 and 1 10. All right, and I'll print x comma x dot shape. So you can see it's having 1 3, like 1 2 3 4 5 6 7 8 9, but now it's having 1 3 3 comma 3 and 1. Right, suppose I want to have like 1 and 9, let's say. So you can see it's a 1 row and 9 columns. All right, suppose I want to have 9 comma 1 now, so it will have 1 column and 9 rows and tensor 1. So this is how we are going to create the first value. All right. If you want to indexing value, go to outer dimension and you can have the inner dimension. So what we'll do, how we can do, we will have x and then 0 and print. You can see we are having first value. If we'll have x and then 0 again, so it will have 0 value. And suppose I am having this value, again I'm going to indexing that value 0 inside this bracket, after this bracket, so it will give 1 again. All right, so this is how we can perform the indexing value and third index value and the respective index value. Right, we can do more indexing part here, like x and then like x value, and then going to have first all rows and the column. Right, so for more clear picture, I'm going to convert this 3 comma 3 and just hit enter, and you can see this one is 1, and okay, so this is the entire row. Right, if you want to check 1 0 1, okay, so 0 2, so this will give last row. And if you want to have 1, so this is will give this one, and if you'll have 1 again, so this will give 5. Right, you want to have, you want to get the 9, so we will have 0 1 2 and 2 again, so we will have 9 here, you can see there. Right, so now if you want to put colon at the first, right, and the 0, we will have 1 2 3. If we replace the 0 by 2, we will have 7 8 9 and so on. So get all values from 0th and first dimension, only index 1 and second dimension. It will have first index and the second index also. So what we are trying to do, we are going to print x and square bracket colon for the entire, for all the values 1 comma 1. You can see 5. So why, so 0 1, so this is second, 0 1, so this is second, 5. So hence we are having 5 values. So again, we are going to index, can be quite confusing to begin with, but especially with large tensor, you can have better visualization and you can have better performance over there. Right, all right, so this is how we can perform the better so many aggregate functions and so many perform values and the repository values and other functions. All right, so we can have other functions and values. Okay, so one more function we can have, like by import random, can have random functions here also. So first what I'm going to do here, I'm going to convert, assign simple seed. So we are going to try changing this to different values and see what happens to the numbers below. So I have just assigned the, like say 21 here, and then torcs torch dot manual underscore seed, and then I'm going to pass that seed is equal to random underscore seed, which is actually 21 here. Right? So then I'm going to assign random underscore tensor underscore c is equal to torch dot rand and then 3 comma 4 and hit run. Right, so we will have to reset the seed every time, new random function and so on. All right, So what we will do, we just assign this y to some value and try to print y here. So you can see it's a generator and it's going to print that value. Now I'm going to print torch dot random, and it's having manual seed, and then seed is equal to random underscore seed. Right, so it's going to try and means line out and seeing the different values. So I'm going to print the random underscore tensor underscore d is equal to torch dot rend, then 3 comma 4 gain. All right, now I want to print the tensor c and d both. All right, this is going to print d, and then we are going to print c again. Right, so you can see this is giving the same value. Right, so it's going to give the same value, and no, so does this equal to this one, and if you want to check the values of this one equal to this one, so are both same? Yes, they are going to have same values. So by how we can have the torch dot random manual seed value this one, and using the random function again after this you will have the same value. Similarly you will have the 21, and you will have the different values over there. Okay, so this is going to convert the torch dot manual seed and the random seed. So similarly you can fix the values of randoms also in this way, and you can have the more values and more another means another parameters. Right, now we are going to import means another device here. All right, so what we will do, we will use like underscore nvidia hashtag under nvidia and smi and hit run. So you can see nvidia is not there, so nvidia smi is not there. So I'm going to run that command. So cut c, going to click on Google and call here in Jupyter. All right, so how to GPU dashboard in Jupyter in NVIDIA, and how to perform the GPU dashboards in you. So we can see that function. All right, so this is going to pip install Jupyter NVIDIA dashboard. Let's see what will happen if we will run this code. Okay, so instead of dollar, it's having this one. Okay, so it's a Jupyter Lab NVIDIA dashboard going to print. Let's see. So tensor Jupyter node NVIDIA DIY, it's going to perform my setup and the CUDA reputation and have GPU name and hold time and another CI/CD. CUDA, you can have CUDA over here, right? Okay, so in here we will have like GPU NVIDIA dashboard. It is going to perform. Okay, so we are going to perform the another functions also. You can see it's going to collect, it's just collected all my requirement and going to perform the proper navigation and all. So it's successfully installed on my SMI and server and so on. So I'm going to add one more thing, that is Jupyter Lab extension and Node.js. It install Node.js and installation is having Node.js org. I need to perform the Node.js. So package manager from Conda and so on. So meanwhile, I'm going to check this again. So cut C to inherit the another media. Okay, so again, NVIDIA's image not recognized as an external command, operable program or batch file. So I think I'll have to download this Node.js and then I'll come back to the same code. So meanwhile, you can install this NVIDIA and CUDA server on dashboard on your PC through this notebook. Thank you.